Hey guys, so today we're going to be doing something called integration by parts, or IBP for short. IBP for short. So this is the formula you're going to want to memorize. The integral of u dv equals uv minus integral of v du. But first, what even is integration by parts? You use integration by parts when you're trying to integrate an integral that can't be solved normally. So you're going to use this formula, okay? And I can't say this enough. This formula, you need to memorize it. It's very, very, very important. Okay? And so if this formula kind of looks confusing at first, that's okay. We're going to go through one easy example, one medium example, and one hard example. And so hopefully by the end, you'll be able to knock these out no problem. All right, so let's go to our first question. Integral of x times e to the x dx. Okay, now, here's our formula. So our first step, we need to choose our u and dv, okay? So here, according to our equation, our formula, u dv, okay? So x is either u or dv, right? We have to pick what u is. So this kind of acronym, LIATE, is how you remember how to choose u. So L is logs, I is inverse trig, A is algebra, T is trig, E is exponential. So it's kind of like PEMDAS, right? Whichever comes first, okay? So x is obviously an algebraic kind of expression. So that's what I'm going to make u, right? So LIATE helps us choose our u. Now, here's a little trick. You always know you chose u wrong if somehow your integral gets harder than when you first started. So I'll show you what I mean. And then dv, well, dv is the rest of the integrand, so this part. So dv is e to the x dx. Now, we're not done yet because our formula requires us to have a v and a du. We only have u and dv. So du is just the integral of x, which is dx, right? And then v would be the integral of e to the x, which is also just e to the x. So now let's plug this all into our master formula up here. So uv, so u is x, v is e to the x, minus the integral of v du, so v is e to the x, and then we said du was dx. Alright? So now, do you see how much easier this became? Right, so that's what I was talking about earlier. You know if you did it right, if your integral becomes a lot easier. So, this would end up being x e to the x minus, well, what's the integral of e to the x? Well, the integral of e to the x is just e to the x, right? So now, we're not done yet, because this is an indefinite integral, right? There's no bounds. So we have to add that constant of integration, plus c. And now, we're done. Boom. Alright, so let's go on to our next question. 2. X squared ln x dx. Integral of all that. So let's write our integration by parts formula. So it'd be integral u dv equals uv minus v integral v du. Alright, that's a little bit messy, sorry. So first, we have to choose our u. Remember what we said. LIATE. Alright? Well, the first thing is logs, and I see a log here, ln x. So I'm going to make u equal ln x. Alright, and then that makes dv equal x squared dx. Alright, so now let's start finding our du and v. Well, du, the derivative of ln x is just 1 over x dx. And then the integral of dv, which will get us v, is going to be x cubed over 3. So now we have all of our parts, and now it's just a matter of substitution. So uv, so ln x, I'm just going to kind of rewrite it, x cubed over 3, so that's uv, minus integral v is x cubed over 3, and du is 1 over x times 1 over x dx. Alright, so now these cancel, so this would be an x squared. Alright, so now I have x cubed ln x over 3. I'm going to factor out this 1/3, right? Not factor out, just pull out that constant. So now I'm left with this, x squared dx. And now this is a lot more simple than x squared ln x dx, right? So again, this is how you know you're going on the right track, because your integral becomes a lot simpler. So now, I have x cubed ln x over 3 minus 1/3 x squared dx. Alright, so let me just move all this up so we have a little bit more space and make it a little bit smaller. So like that. Okay, so now let's do our regular integration. So it'd be x cubed ln x over 3 minus 1/3. And then the integral of x squared is just going to be x cubed over 3, right? So now this is, we can leave it like this, right? But I'm just going to simplify just one more step further. Ln x over 3 minus x cubed over 9. And then plus c. Again, because we don't have our bounds. So this is an indefinite integral. Okay? So I hope this is kind of making a little bit more sense as we go. And then our next question, we're going to actually, well, actually, no, I'll let you guys see for yourself, okay? All right, so here's our next question. Integral x squared times e to the negative x dx. All right, so again, we're going to use our integration by parts. And this is how you know if it's an integration by part. If it's a multiplication of two different forms of math, right? That's how I think about it, at least, right? So if it's an algebraic expression minus or times exponential, then I know I have to use integration by parts. Or if it's an exponential and a trig, then I know I have to use integration by parts. Stuff like that. So let me just write down our formula. Integral dv equals uv minus integral v du. All right. So you see, once you practice it a lot, like this equation just becomes second nature to you. All right. So let me first write out the a. Okay. So now let's pick our u. Well, let's look at our the stuff in our integrand. Well, this is an exponential, right? And this is an algebraic. An algebraic comes before the e. So I'm going to make that our algebraic, x squared. So that means dv has to be e to the negative x dx, and then du, right? Why do we need du? Because that's in our master equation, and same with v. So du would just be 2x dx. Alright, so now let's do v. So this would be the integral of e to the negative x is just negative e to the negative x. Oops, that's a bad x. That's also a bad x. Oh my god. There we go. Okay, so now, again, let's do our substitution. Okay, so first, u, v, we're going to put it in. So, I'm going to switch the order around. X squared e to the negative x minus the integral of v is negative e to the negative x. And du, we said, was 2x dx. Alright. Alright, so now that we have this, let me just kind of simplify it as much as I can. So I'm going to put out a negative 2, right? So this will be plus 2 integral e to the negative x dx. Alright. So do you guys notice this kind of looks very, very, very much similar to our original integrand? So what does that mean? That means we're going to have to do integration by parts again. Alright? So there are questions where you're going to have to do integration by parts multiple times. Next video we'll be going over kind of a simpler way to do it. But first, we need to talk about something very important. When you do integration by parts multiple times, you cannot change your u. We made u the algebraic expression in our integrand, right? We made u x squared. So we're going to make u the algebraic expression again in this integration by parts. So in the second integration by parts, we're going to focus on this, right? So we can't change our u, okay? The u is going to be still the algebraic part of our integrand. You cannot change that no matter what, okay? So just remember that. So now let's do our integration by parts again. It's a little bit tedious, but you do what you got to do. So we're going to make u our algebraic part, and then dv is just going to be whatever's left, right? So negative e to the negative x dx, and then we find our du, which is just dx, and then we find our v, which is just negative e to the negative x. Alright? So now we're going to plug everything back in again. Alright, so I just copy pasted it onto the next slide so we have a little bit more space to work with. So now we're just going to, let me just write the formula again. So integral u dv equals uv minus integral v du. Alright, so if you learn anything from this video, just memorize this formula. Alright? Alright, so now let's just plug our ingredients, quote-unquote ingredients, into our recipe. So uv, it'd be x, and then v is negative e to the negative x, minus the integral of v is negative e to the negative x, and du is dx. Alright, so now we see, okay, this has gotten a lot simpler. So now let me just make it negative x e to the negative x plus e to the negative x dx. Okay, so now we can just simplify this negative x e to the negative x. The integral of e to the negative x is just minus e to the negative x. And then, are we done? No. We have to add our constant of integration. We just solved for this. We want to find this whole orange equation, right? That's what we wanted to solve for in the first place, right? That's what we got. So now we have to plug everything back in. So let's plug everything back in. I'm actually gonna, let me just erase the c. I'm gonna put c at the end, and you'll see what I mean. So this would be negative x squared e to the negative x plus 2 times. So the integral of this is just this small little equation right here. Oops. So it'd be negative x e to the negative x minus e to the negative x. And then I'll tack on a c at the end. It's maybe not the most mathematically correct, but it's alright. Now you can leave it like this. In fact, I am gonna leave it like this. I'm sure you guys know how to distribute, right? Just multiply this 2 out. Alright, so then I'll just circle this. So here is our answer. Alright, so now we went through all of our examples. So, by the way, so the answer to this, integral x squared times e to the negative x dx, is this, which is a little bit crazy, right? You can't, before you watch this video, you wouldn't have known how to integrate that. So, I hope you guys learned a lot for this question, for these types of problems, integration by parts. We went through easy, medium, and hard. Probably this is going to be one of the hardest that you're going to see on the AP exam. Next video we'll be going over tabular integration, which is kind of an easier way to go about solving question number 3. But I just wanted you guys to see how to tackle all different types of problems. But anyway, thank you guys so much for watching. If you have any questions, leave them down below in the comments. I'll answer as many as I can. Like, subscribe, do all that. And I'll see you guys in the next video. Thank you guys so much.